As network engineers, generally speaking, we know how a network treats different types of traffic. So unicast traffic and broadcast and multicast traffic are all treated a specific way by the switches and routers within our network. Well, ACI changes the rules for some of that. In this nugget, we're going to be taking a look at exactly how ACI treats broadcast traffic within the fabric. In traditional networking, when we have a switch with a bunch of different interfaces on it, we know that if a broadcast packet were to come in on one of those interfaces, then the switch has no choice but to send that broadcast packet out every single interface. And this is intentional because usually one of two scenarios is happening. Either one, we're trying to reach somebody who we don't know where that person is, so it's unknown. Or number two, we're trying to reach multiple destinations all at once. The problem is, in a lot of cases, this number one here is the problem. We don't know where we're trying to get, and so by sending this broadcast packet in, really I'm just trying to reach the host that's over here, maybe a laptop computer plugged into this switch port, and guess what? I just generated 5 times as much traffic as needed in order to reach that host. Now, unfortunately, while there's no way to get around this, we can limit the scope by creating what we call broadcast domains. And really, a broadcast domain is a VLAN. And so we can create multiple VLANs on the switch to limit the scope of the broadcast domains. And so by putting maybe these two interfaces down here in VLAN 10, and then we'll put these two interfaces up here in VLAN 20, and we'll keep the other interfaces in, let's just call this VLAN 30 here in the middle. Well, now when that broadcast traffic shows up in VLAN 30, the interfaces for VLANs 20 and 10 are not going to forward that traffic. This is the concept of a broadcast domain, and it's been around in networking for a long time. But this is also where ACI turns this behavior on its head. And ACI does that by way of what we call a bridge domain. Now, if you haven't yet seen the series, the ACI logical model, then be sure to check that out because we're going to assume that we have a base understanding of what a bridge domain is and how it fits into that logical model for ACI. Now, inside of a bridge domain are endpoint groups. These endpoint groups are a collection of endpoints. It's a group of endpoints. This is an EPG, and we have endpoints attached to it. So maybe we have VMA and VMB. So 2 different virtual machines that are attached to that endpoint group. And maybe over here we have VMC. Now let's say we have a second bridge domain as well. We'll just say this is BD2. And again, we've got a couple of endpoint groups in here. And so here we'll have virtual machine D. Now this is great all being in the logical world, but what's this look like in the physical world? Because at some point we do have physical switches. And so we'll draw this out real quick as a small ACI spine and leaf architecture, where we have a couple of spine switches and a couple of leaf switches. And leaves connect to spines and spines to leaves, but spines don't talk to spines and leaves don't talk to leaves. And to make things simple, let's just say that the virtual machines all hang off of 4 different interfaces in the spine and leaf environment. And so we have VMA here on the left with VMB, and then we also have VMC and VMD here on the leaf on the right. Now let's just say that these EPGs are all tied to different VLANs. And so we have VLANs 10, 20, 30, 40, and 50. And so virtual machines A and B are on VLAN 10, for example. Now in a traditional network, if VMA were to send a broadcast out, it would get forwarded to everybody in VLAN 10, namely VMB would also get a copy of that broadcast packet. So in our physical world here on the right, we have VLANs 10, 10, C as in 30, and D as in 50. And so again, looking at it traditionally speaking, VMs A and B, they should be able to receive each other's broadcast packets. But a bridge domain is akin to a broadcast domain as well. And so because the broadcast domain is part of the bridge domain and includes all of the EPGs that are within that bridge domain, well, guess what? Not just VMB, but VMC is also going to receive a copy of that broadcast. Well, what's going on here? Well, ACI is trying to do away with this concept that VLANs and subnets define our policy. This is not good practice. This is how our networks today are built, unfortunately, where if I want a virtual machine to be part of a particular policy, then I really need it to be in a specific VLAN. In other words, if I have a bunch of database servers, maybe this EPG in Bridge Domain 2 is a set of database servers. In traditional networking, they would all need to be part of, let's say, VLAN 40 in order to share the policies that we've defined for our database servers. However, in ACI, the endpoint group is king. And so because we have EPGs, we want the EPGs to define the policy. Because of this, VLANs are no longer as relevant as they used to be. They're still important because we use them to identify the traffic as it comes in on a leaf switch, for example, VLAN 10 on that specific port is going to tell us that, hey, we're part of this particular EPG here on the left. But it's really about identification, not about policy anymore. And so we're heading towards the application-centric view within ACI, which is to say that what I really care about is the virtual machine itself. I want to apply policy to this virtual machine, not to the VLAN or the subnet, but to the specific hosts in my environment that require that policy. So we need to keep in mind with ACI, when we create a bridge domain such as we did here on the left, where we have multiple endpoint groups spreading multiple VLANs, that turns that into one large broadcast domain. So any broadcast sent by any of the hosts inside that bridge domain will be forwarded to all the other endpoints also within that bridge domain. Okay, long story short, in ACI, the broadcast domain is now defined by the bridge domain. So in traditional networks, we could have broadcast domain isolation by putting hosts into different VLANs, but in ACI, that's no longer guaranteed, because if those endpoints are part of endpoint groups that are in the same bridge domain, they will see each other's broadcast traffic. I hope this has been informative for you, and I'd like to thank you for viewing.